Okay, this is a review from section 5.5 and 5.6 really. So you're given a cubic function here, and it says to factor it completely if you know that f of 7 equals 0. So remind yourself, first of all, when f of 7 equals 0, that means when you put 7 in for all of the x's, you should get 0. So if I know it's a 0, I can utilize that and do synthetic to go from a cubic down to a quadratic, and then hopefully that quadratic will factor. And I promise you, if I'm asking you to factor something, I'll make it factorable. Okay, so I'm going to synthetically divide by 7, since that's I know a solution. All my coefficients of that cubic function are, and everything's given there, not missing anything. So carry down and do this process. And you pause the video, of course, and make sure you can do this. Okay, and synthetically, I got a 0 remainder, so that's good. And I went from a cubic down to a quadratic. So hopefully that's factorable. I'm going to go ahead and do the Fifo method, not that you have to. But again, keep in mind the point of this problem is we want to factor. We're not solving anything, even though we were given a solution, so don't get confused. So if I do Fifo, 3 times 10 is 30, and factors of 30 that add to 17 would be 15 and 2. So what I'm going to do then is I'm going to take my first term, 3x, and I'm going to do a plus 15, and I'm going to take my first term, 3x, I'm going to do a plus 2. I can take a 3 out of this one, so it's really x plus 5 and 3x plus 2, and then go ahead and double check. You know, when you FOIL this out, x times 3x is 3x squared, 5 times 2 is 10, plus 2 plus 15, sure enough, that works out. So factor completely, and this is the tricky part. This factors down to my quadratic, but I need to be a cubic. So if I'm given a solution of 7, its factor would be x minus 7, and all three of these factors multiplied out, of course, would give me this cubic back again. So forgetting to turn this into a factor is sometimes that often happens, so just be careful. Okay, there will be a problem on your exam as simple as this, where it just says list all the possible rational zeros for the following polynomial function. So you literally just have to list them. You don't have to actually find them. So remember that that's all factors of your constant. So that would be 1, 3, 5, and 15 divided by all the factors of your leading coefficient, which are 1 and 3. And it's plus or minus all of those. So I'm going to start with 1. So I know it's 1 over 1 and 1 over 3. So that's obviously 1 and 1/3. Then I'm going to scooch to 3, so 3 over 1 and 3 over 3. So 3 over 1 is 3, but 3 over 3 is just 1 again, so I don't need to repeat it. 5 over 1 and 5 over 3, so that's 5 and 5/3. And lastly, 15 over 1 and 15 over 3, but that's 5 again, so I only need 15. And there's all of your possible rational zeros. Okay, last one, and I might give you a little hint on the test. So given this cubic function, find all of the zeros, and the hint to you is that 1 or -1 is a 0. So this would be a no calculator question, hence I might give you a little help so that you don't have to sit and test all the possible rational roots. So good news is I could find all the factors of 22 divided by 1, but I've given you a hint that 1 or -1 works out, so I'm just going to go ahead and try 1 first. So if I take 1 and I take all of my coefficients here, so I'm going to carry down, and that worked out nicely. So that means that I went from a cubic to a quadratic, and I need to find all the other zeros. So now at this point, it's certainly up to you. You can solve this quadratic however you want. Maybe it's factors. If it doesn't, then you would use the quadratic formula. And I don't think there are any factors of 22 that would add up to 4. So 11 times 2, nope, that won't work. And obviously 22 and 1 does not work. So I'm going to go ahead and use the quadratic formula. So x equals the opposite of b, plus or minus b squared, minus 4ac is really going to be plus 88 all over 2a. and that is the square root of 104. And then we have to, of course, break down our radical, so I know, or, you know, with a little bit of thought, I know that there is a perfect square in 104. So 104 happens to be 4 times 26, and I know that the square root of 4 is 2. And then 2 divides into both of those, so I really have 2 plus or minus 1 root 6. So there are my 2 solutions, and then I was given, well, a hint that also positive 1 worked out. So altogether I have 3 solutions. 2 of them are irrational and 1 of them is rational.